Alright, so here goes the first interesting application problem of conic sections. Halley's Comet has an elliptical orbit with the Sun at one focus. Well, that's kind of cool if you think about this situation. There's the Sun, and here's the orbit of Halley's Comet. The eccentricity of the orbit is 0.97. So we know the eccentricity, which is in the form c over a, we know that is approximately 0.97, which will come in handy later. The length of the major axis of the orbit is approximately 36.18 astronomical units. What on Earth is an astronomical unit? Well, it's not on Earth. It is a space unit. And so we have the length of the major axis, which has to be 2a, equals 36.18. Which means that our A value, is actually half of 36, which is 18, and half of 0.18, which is 0.09. So A is 18.09, which then means that C over 18.09 equals the eccentricity, 0.97. And so then C will have to equal 0.97 times 18.09, and I can figure out what that is, which is this ugly number, 17.5473. And what else do I know? Well, I know that when writing this equation, it's totally okay to put the center at the origin, which means I'll just have an x squared plus a y squared equals 1. It has not been shifted left or right. And I'm going to let the major axis lie on the x-axis, which means this needs to be horizontal, which means a needs to be with x. So a squared over b squared, like that. So I really need to just find b. Because I have a, so I can get a squared. I have c, so I can remember that a squared equals c squared plus b squared. Let's plug in what we know. 18.09 squared equals 17.5473 squared plus b squared. And so b squared equals this ugly mess, 18.09 squared minus 17.5473 squared. Let's figure out what that is real quick. And although I can find that b is 19.340 is what we're going to round that to. I'm sorry, b squared is that. Let's do an approximate symbol, which means that b is roughly the square root of that, which is roughly 4.398. So we have a and b, so all we need to do is write the equation, x squared over a squared, so 18.09 squared, plus y squared over b squared, so 4.398 squared equals 1, makes that the equation of Halley's Comet. Halley's Comet?